What if I told you the very first time traveler could be hiding in plain sight, not in some distant corner of the cosmos, but woven into the fabric of the universe itself? The idea of time travel has always felt like science fiction, a playground for movies and novels. But what if it's not just fantasy? What if the universe has already experimented with time travel, leaving clues scattered across space and time for us to discover? Today, we're diving into 30 mind-bending theories that suggest the first instance of time travel might not be something humanity invents, but something the universe itself has already accomplished. Picture this: a cosmic anomaly, a ripple in the laws of physics so subtle we've barely begun to notice it. Scientists have long debated whether time travel is theoretically possible, but few have considered the possibility that it's already happened. From black holes bending time like a folded sheet of paper to quantum particles seemingly teleporting between moments, the evidence, or at least the tantalizing hints, might already be staring us in the face. Some theories propose that the Big Bang itself could have been a time loop, a crack in reality that sent the first traveler hurtling backward or forward. Others suggest that ancient civilizations long lost to history might have left behind artifacts that defy linear time. This isn't just about wild speculation, it's about peeling back the layers of reality to ask questions that challenge everything we think we know. Over the course of this journey, we'll explore theories that range from the scientifically plausible to the downright astonishing. Could dark matter be the residue of a time traveler's journey? Is the cosmic microwave background hiding encrypted messages from the future? And what if the universe's first time traveler isn't a person at all, but a fundamental force of nature? Strap in, because we're about to take a trip through possibility where the only limit is the imagination of the cosmos itself. The first theory might rewrite the origin story of everything. What if the Big Bang wasn't the beginning, but the end of a time loop? Imagine a traveler from the far future, armed with knowledge or technology beyond our comprehension, journeying back to the moment of creation. But instead of observing, they trigger it. This would mean the universe didn't just appear from nothing, it was kick-started by its own future. A paradox so profound it bends the very idea of cause and effect. Physicists like Roger Penrose have flirted with similar ideas, suggesting that under extreme conditions like those inside a black hole, the laws of time could twist into something unrecognizable. In loop quantum gravity, time isn't a straight line. It's a network of interconnected moments where the future could theoretically reach back and influence the past. If true, the Big Bang might not be a singular event, but a cosmic reset button pressed by something or someone from the other side of time. Think of it like a snake swallowing its own tail, an infinite cycle where the end is the beginning. Some models even suggest that the universe's expansion could eventually reverse, collapsing back into a singularity only to explode outward again in another Big Bang. Could this cycle be evidence of time travelers manipulating the fabric of reality, ensuring the universe recreates itself over and over? If so, the echoes of their actions might still linger in the faint ripples of the cosmic microwave background, like fingerprints on the very first moment of existence. This wouldn't just change our understanding of time, it would redefine the purpose of the universe itself. Maybe time travel isn't just possible, maybe it's inevitable. Now let's shift our gaze from the birth of the cosmos to the cradle of human civilization, because what if the first time travelers didn't just tamper with the universe's beginnings but walked among us? The ancient astronaut hypothesis suggests that advanced beings, possibly from the far future, visited Earth thousands of years ago, embedding their knowledge into structures that still baffle us today. Take the Great Pyramid of Giza, a marvel of engineering so precise that modern architects struggle to replicate its alignment with celestial bodies using 21st century tools. Or the Nazca Lines, massive geoglyphs carved into the Peruvian desert, invisible from the ground but forming clear, intricate designs when viewed from the sky. almost as if they were meant for someone looking down from above. Could these be more than just ancient art or religious monuments? Some researchers argue they're blueprints, maps, or even messages left by visitors who understood time as a fluid dimension. The precision of these structures raises eerie questions. How did civilizations without advanced technology achieve such feats? And why do so many ancient cultures, separated by oceans and millennia, share eerily similar stories of gods descending from the stars, wielding knowledge far beyond their time? This theory gains even more traction when you line it up with modern phenomena. Recent declassified government reports on unidentified aerial phenomena (UAP). The new term for UFOs describe aircraft performing maneuvers that defy our understanding of physics. Pilots have recorded objects accelerating instantaneously, making 90-degree turns at hypersonic speeds and vanishing without a trace. If these aren't human-made, could they be evidence of the same travelers who once walked among the ancients, now checking in on their handiwork? Skeptics dismiss these ideas as fantasy, but the connections are hard to ignore. Ancient texts like the Hindu Vedas describe flying machines called vimanas with details that sound eerily like advanced propulsion systems. The Sumerian king list speaks of rulers who lived for tens of thousands of years, a glitch in time or a record of beings unbound by its limits. Even the Bible's book of Ezekiel paints a vivid picture of a wheel within a wheel, descending from the heavens, accompanied by fire and thunder. Perhaps the most chilling possibility is that these visitors weren't just passing through. They were deliberately shaping human history. Did they accelerate our evolution, spark our earliest technologies, or even tweak our DNA? And if they're still out there, observing from the shadows, what might they be waiting for? The answers could rewrite not just our past, but our future. The idea of a self-creating universe sounds like something straight out of a sci-fi epic, but what if it's not just fiction? Imagine a being from the far future, so advanced they've mastered time itself, reaching back to the moment of creation to tweak the cosmic settings, ensuring their own existence. This isn't just a wild thought experiment. It's a theory that intersects with some of the most cutting-edge ideas in physics and philosophy. Think of it like a programmer writing code for a simulation, meticulously adjusting the parameters so that everything unfolds exactly as planned. Only in this case, the programmer is a time traveler and the simulation is our reality. Futurists like Ray Kurzweil have long speculated about the so-called singularity, a point where artificial intelligence surpasses human intelligence and merges with it, creating beings capable of manipulating time and space. If such entities exist, could they have orchestrated the universe's birth to guarantee their own emergence? It's a dizzying paradox, the creator and the created locked in an endless loop, each relying on the other to exist. This idea dovetails eerily with simulation theory, which suggests our universe might be an artificial construct, a hyper-advanced digital reality. If true, the programmer could be a descendant of humanity, fine-tuning the Big Bang's conditions to ensure their own timeline unfolds without a hitch. The math behind this theory is just as mind-bending as the concept itself. Cosmologists have discovered that the fundamental constants of the universe, like the strength of gravity or the charge of an electron, are perfectly calibrated to allow life to exist. Tweak any of them even slightly and stars wouldn't form, atoms wouldn't bond, and life as we know it would be impossible. This fine-tuning problem has puzzled scientists for decades. Some call it luck, others see the hand of a designer. But what if that designer isn't a god or an alien, but a future version of ourselves? Consider the implications. If the universe was engineered to produce time travelers, then every galaxy, every particle, every law of physics might serve a hidden purpose, a cosmic breadcrumb trail leading to their existence. It would mean free will is an illusion, destiny is prewritten, and the entirety of history is just a carefully crafted setup for a single moment in the far future when someone flips the switch and becomes their own ancestor. And here's the real kicker. If this theory holds water, we might already be living in their experiment, following a script we don't even know exists. The next time you gaze up at the stars, ask yourself, are we the creators, the created, or both? The answer could rewrite not just science, but the very story of existence. What if the greatest inventions in human history weren't actually invented, but handed to us by someone from the future? Imagine a time traveler stranded in the past, forced to jump-start the very technology that would one day allow their own existence. This is the heart of the bootstrap paradox, a loop with no beginning where the effect creates its own cause. Take electricity, for example. The sudden leap in our understanding during the 18th and 19th centuries feels almost unnatural. One moment we're rubbing amber with fur to make sparks, the next we're harnessing lightning itself. Could someone have slipped Nikola Tesla a few blueprints, setting off a chain reaction that led to the modern world? The same eerie pattern emerges with nuclear fission. The Manhattan Project scientists often described their breakthroughs as moments of inexplicable clarity, as if the answers were handed to them. Enrico Fermi, the architect of the first nuclear reactor, once joked that his team seemed to be standing on the shoulders of giants who left no footprints. What if those giants were time travelers, ensuring humanity unlocked atomic energy precisely when needed to forge the future they came from? This wouldn't just explain rapid advancements. It would mean our entire technological timeline is a carefully orchestrated loop, with each invention predestined to enable the next. Physics even leaves room for this madness. Quantum mechanics allows particles to exist in superposition, effectively being in multiple states until observed. Some interpretations suggest reality branches with every decision. So why couldn't one of those branches be a timeline where a traveler plants the seeds of their own origin? The equations don't forbid it, they just make our heads hurt. Think of it like a novel where the author writes themselves into the story, then burns the original manuscript. The book can't exist without the author, but the author can't exist without the book. Now replace book with civilization, and you've got the bootstrap paradox in full swing. Ancient cultures might have sensed this. The Greek myth of the Ouroboros, a serpent eating its own tail, symbolizes cycles without end. The Hindu concept of karma suggests actions ripple across lifetimes. Could these be intuitive grasps at a truth science is only now confronting? Here's where it gets truly unsettling. If the bootstrap paradox is real, there's no first version of history. Just an infinite hall of mirrors where cause and effect chase each other forever. Every light bulb, every microchip, every spaceship could be part of a self-sustaining loop, with no creator, just an endless echo of creation. That means you might be reading this script because somewhere in the future, someone needed you to. The multiverse might hold the key to the universe's first time traveler, not from our past or future, but from a reality entirely separate from our own. Imagine a being from a parallel dimension, slipping through the cracks of space-time during the universe's earliest moments, when the fabric of existence was still stretching and unstable. According to the many worlds interpretation of quantum mechanics pioneered by physicist Hugh Everett, every possible outcome of an event spawns a new universe. In this infinite sea of alternate realities, one traveler could have crossed the divide, arriving in our timeline not as a visitor from the future, but as a refugee from another cosmos. This wouldn't just rewrite the rules of time travel, it would shatter them. Most theories assume time travelers move along the axis of past and future, but what if the first leap wasn't through time at all, but across dimensions? During cosmic inflation, the universe expanded faster than the speed of light, creating conditions where the boundaries between realities might have been thin enough to breach. Think of it like two soap bubbles colliding. For a fleeting instant, their surfaces touch, and something could pass between them. If a traveler from another universe slipped through during that moment, they wouldn't just be a relic of the past, they'd be a living paradox, a being with no origin in our timeline. Recent multiverse research adds weight to this mind-bending idea. Experiments with quantum entanglement show particles influencing each other instantaneously across vast distances, as if they're connected through some hidden layer of reality. Some physicists like Max Tegmark argue this could hint at overlapping universes where information leaks between worlds. If that's true, could an entire consciousness or something even stranger have made the jump? Ancient myths speak of gods descending from other realms, often described as shimmering or indistinct, as if they weren't fully anchored to our world. Could these stories be garbled accounts of interdimensional travelers, misinterpreted through the lens of pre-scientific cultures? The implications are staggering. If the first time traveler came from a parallel universe, they might not operate by our laws of physics. Their very presence could have altered the trajectory of our reality, tweaking fundamental constants or seeding anomalies we're only now beginning to detect. Dark energy, the mysterious force accelerating the universe's expansion, might not be a natural phenomenon. It could be the residue of their crossing, a scar left by their transition into our world. Even more unsettling, if they arrived once, what's stopping others from following? The multiverse might not just be a curiosity of quantum theory. It could be a highway for travelers we're not even equipped to recognize. So the next time you hear a scientist dismiss time travel as impossible, remember, the rules might be far stranger than we think. The first traveler wasn't bound by our linear clock. They were something else entirely, a tourist from a reality where impossible doesn't exist. What if the universe isn't just a collection of stars and galaxies, but a living, thinking entity, one so vast it perceives past, present, and future all at once? This theory flips everything we know about time travel on its head. Instead of machines or wormholes, imagine consciousness itself as the ultimate time-traveling vehicle. At the moment of the Big Bang, the universe might have remembered its own future, folding time into a loop where creation and destiny are inseparable. This isn't just poetic speculation, it's rooted in panpsychism, the philosophy that consciousness is a fundamental property of all matter, from atoms to galaxies. Think of it like a dreamer who knows the ending of their dream before it unfolds. If the universe has a form of cosmic awareness, its earliest moments could have contained the imprint of everything to come, including the rise of civilizations, the birth of black holes, even its own death. This would mean time isn't linear at all, but a tapestry the universe weaves while simultaneously observing every thread. Some physicists, like Giulio Tononi, suggest consciousness arises from the complexity of information integration. Apply that to the cosmos, and you get a mind so expansive it experiences all of time in a single, timeless now. The evidence might be hiding in plain sight. Quantum entanglement, where particles instantaneously influence each other across vast distances, hints at a universe deeply interconnected in ways we barely grasp. If particles can communicate faster than light, could the cosmos itself be sharing information across time? Ancient mystics and modern scientists alike have pondered this. The Hindu concept of Brahman describes the universe as a single, conscious reality. Even Carl Jung's collective unconscious suggests a shared layer of memory transcending individual minds. Could these ideas be glimpses of a truth science is only beginning to articulate? Here's where it gets wild. If the universe is self-aware, then our own attempts to understand time travel might not be discoveries. They could be the universe remembering itself through us. Every equation, every telescope, every theory could be part of a cosmic feedback loop where the observer and the observed are one and the same. This would mean the first time traveler wasn't a person or an alien, but reality itself, peering into its own reflection across the eons. The implications dissolve the line between physics and philosophy. If consciousness is woven into the fabric of space-time, then free will and determinism might not be opposites but two sides of the same coin. Our choices could be both uniquely ours and part of a grander pattern, like cells in a body unaware they're collaborating to form a thought. Maybe the universe didn't just allow time travel, it invented it by dreaming itself into existence. And if that's true, we're not just living in the universe, we're how it knows itself. Dark matter, the invisible glue holding galaxies together, might be more than just a cosmic mystery. It could be the ultimate time capsule, hiding secrets from the dawn of existence. Scientists estimate dark matter makes up about 85% of the universe's mass, yet it doesn't interact with light or ordinary matter in any way we can detect. That's not just a scientific headache, it's the perfect camouflage. If you wanted to send a message across billions of years or stash evidence of time travel where no one would accidentally stumble upon it, dark matter would be the ideal vault. Think of it like an encrypted hard drive floating in space. We can sense its gravitational pull, but the data inside remains locked. Some researchers speculate that dark matter's unusual properties, its refusal to collide with normal matter or emit radiation, might not be accidental. What if it was engineered to preserve information? Imagine a civilization so advanced they could encode their history, or even their very essence, into particles that outlast stars. These wouldn't be radio signals or stone tablets, but something far more durable, quantum imprints woven into the fabric of reality itself. This idea isn't as far-fetched as it sounds. Quantum physics allows for information to be stored in the spin of particles or the entanglement between them. If a time traveler wanted to leave a message for the future, embedding it in dark matter would guarantee it survives supernovas, black holes, and the heat death of the universe. We might even have already detected hints of this without realizing it. Some dark matter experiments have picked up unexplained anomalies, tiny energy fluctuations that don't match any known particle. Could these be fragments of a signal waiting for us to crack the code? And here's the spine-tingling twist. Dark matter might not just carry messages. It could be the traveler. Certain theories propose that dark matter isn't a single substance but a whole spectrum of exotic particles, some of which might possess properties beyond our comprehension. If a being could transform itself into a form of dark matter, it could traverse time undetected, like a shadow slipping between seconds. Ancient myths speak of incorporeal entities, spirits, gods, or ancestors existing just beyond perception. Could these stories be echoes of encounters with something woven from the same invisible threads that bind the cosmos? The kicker, we may never know for sure. Dark matter doesn't just hide its secrets, it defies observation by design. But that's what makes it the perfect hiding place. If the universe's first time traveler is still out there, they're not lurking in some distant galaxy. They're all around us, threaded through the emptiness between stars, watching and waiting from a dimension we're only beginning to suspect exists. The answers might be closer than we think, if we learn how to look. What if the first time traveler wasn't a person, but a single act of observation, a moment when the universe blinked into existence by being seen? This theory hinges on one of quantum mechanics' most baffling experiments, the double slit. When scientists fire particles at a barrier with two slits, they behave like waves, creating an interference pattern on the other side, unless someone tries to measure which slit each particle passes through. The instant an observer steps in, the particles choose a path, collapsing from a haze of possibilities into a single reality. Nobel Prize-winning physicist John Wheeler took this further, proposing that the universe only becomes concrete when observed, meaning consciousness itself might shape the fabric of reality. Now stretch that idea to the very beginning. Picture the newborn universe as a quantum soup, every possible version of itself overlapping in a cosmic haze of maybes. Then, somewhere in the future, the first conscious being, a starfish, an alien, a human, looks back. That observation, like a cosmic keystroke, could have selected one timeline from the infinite menu, retroactively determining which Big Bang played out. In this scenario, time travel isn't about moving through history, it's about creating it by witnessing it. The past wouldn't be fixed until the future chose it, like a book whose ending writes the first chapter. Wheeler called this the participatory universe, where reality is a collaboration between the observed and the observer. Ancient Vedic philosophies described something eerily similar, the idea that the world is illusion until perceived. Even modern quantum computing relies on this principle. Qubits exist in multiple states until measured, at which point they snap into focus. If consciousness truly has this power, then the first time traveler didn't need a machine. They just needed to pay attention. Here's where it gets stranger. If observation defines reality, then every act of looking could be subtly editing the past. A scientist measuring a particle today might inadvertently tweak the conditions of the early universe, like ripples flowing backward through time. This wouldn't violate causality, it would redefine it. The universe wouldn't have a single history but a web of potential histories constantly reshaped by future eyes. The implications are dizzying. It would mean we're not just living in the universe, we're completing it. Every time you glance at the stars, you might not just be seeing light from the past. You could be holding up a mirror to creation itself, reflecting the moment it decided to exist. The first time traveler wasn't a rebel breaking the rules of physics. They were the artist who finally gave the canvas its shape. Black holes aren't just cosmic vacuum cleaners. They might be the universe's oldest time machines. Picture a newborn black hole in the chaos just after the Big Bang. Its gravitational pull so intense it doesn't just bend space, it fractures time. According to Einstein's general relativity, the closer you get to a black hole's event horizon, the more time slows down. But what if something crossed that boundary, not to be crushed but catapulted? Some theories suggest that under the extreme conditions of the early universe, black holes could have acted like temporal whirlpools, spitting out not just matter but moments. Stephen Hawking's groundbreaking work on black hole radiation adds fuel to this fire. Hawking radiation, the faint glow of particles escaping a black hole's grip, implies these cosmic monsters aren't eternal. They evaporate, leaving behind whispers of their existence. But here's the twist. Quantum mechanics suggests information can't be destroyed, so where does it go? The holographic principle proposes that everything swallowed by a black hole isn't lost, but encoded on its surface like a cosmic hard drive. If that's true, could a traveler from the future have hitched a ride on this quantum data stream, emerging in the past as a reconstructed echo of themselves? Imagine a being from a far-flung civilization, purposefully plunging into a black hole not to die but to reboot. As their atoms unravel, their essence, memories, consciousness, even intent gets etched onto the event horizon. When the black hole eventually evaporates, that information doesn't vanish. It's released back into the universe, a message in a bottle tossed backward through time. The traveler wouldn't arrive as flesh and blood, but as a pattern woven into the fabric of reality itself, like a ghost in the cosmic code. This isn't just speculation. Certain solutions to Einstein's equations, like the Kerr metric, describe black holes with spinning interiors that could theoretically form tunnels, wormholes connecting distant times. In the early universe, where laws of physics were still settling, these tunnels might have been unstable bridges rather than dead ends. A traveler wouldn't need a machine, they'd just need perfect timing and a black hole born at the right moment. Ancient myths speak of heroes descending into underworlds and returning transformed. Could these stories be garbled accounts of encounters with beings who rode black holes into the past? The eerie part, we might be surrounded by evidence. Primordial black holes, hypothetical remnants of the universe's infancy, could still drift through space today. If one passed near Earth, its gravitational lensing might bend light in ways that reveal not just its presence but anomalies, like faint, impossible patterns in the cosmic microwave background. These wouldn't be natural fluctuations, they'd be signatures, graffiti left by something that shouldn't exist yet. the first time traveler might not be hiding in the future. They could be etched into the sky, waiting for us to decipher the darkness. The first moments of the universe weren't just a fiery chaos, they might have been a carefully crafted signal, a message from the dawn of time itself. During the Planck epoch, the universe was so dense and hot that the laws of physics as we know them didn't exist yet. Space and time were tangled, fluctuating in ways that defy imagination. But what if something in that primordial soup wasn't just reacting, it was communicating? Some scientists believe the cosmic microwave background, the afterglow of the Big Bang, could contain deliberate patterns like cosmic Morse code etched into the fabric of reality. Take the so-called axis of evil, one of the most baffling anomalies in the CMB. This unusual alignment of temperature fluctuations stretches across the sky in a way that defies standard cosmological models. It's as if the universe has a preferred direction, a fingerprint that shouldn't exist in an isotropic cosmos. Could this be more than a random quirk? Theoretical physicist Ranga Ramchari once detected unexplained bright spots in the CMB's microwave haze, regions that glow slightly more intensely than the surrounding radiation. He described them as potential bruises from collisions with other universes, or perhaps deliberate markers left behind by something far older than stars. The mechanics of such a message would be unlike anything we're familiar with. In the Planck epoch, time and space were so tightly wound that causality was fluid. A being existing in that primordial state wouldn't need to send a message forward in time. It could imprint its intention directly onto the underlying structure of spacetime, like pressing a seal into wet clay. As the universe expanded and cooled, that imprint would stretch and warp, eventually freezing into the CMB we observe today. The message wouldn't be written in words or symbols, but in the very geometry of the cosmos. Decoding it would require thinking in entirely new dimensions. Imagine trying to read a sentence where each letter is a fundamental constant of nature, the strength of gravity, the mass of an electron, the speed of light. Tiny deviations from expected values might not be errors, but syllables in a language we haven't learned yet. Some researchers, like Anthony Z., have speculated that the universe's fine-tuning could be a form of mathematical poetry, its equations hiding deeper layers of meaning. If true, the Planck epoch messenger wouldn't just be talking to us. It might be the reason we exist to listen. The most haunting possibility, we might not be the intended recipients. The message could be a beacon for civilizations yet to rise, or a warning from a creator who knew their experiment would one day need guidance. Or perhaps it's simply a signature, the universe's way of reminding us that every beginning has an architect. As our telescopes grow sharper and our models more refined, we might finally glimpse the fingerprints of that first, fleeting intelligence, not in the stars, but in the silent afterglow of creation itself. What if the singularity that birthed the Big Bang wasn't just a point of infinite density, but a time traveler caught in the ultimate paradox? Picture this, a being from the far future, armed with knowledge or technology beyond our comprehension, attempting to journey back to the very beginning of time. But instead of arriving safely, they're crushed into the singularity itself, their mass and consciousness compressed into that infinitely small, hot point. Their death becomes the spark that ignites the universe, their remains scattering as the first particles of matter and energy. This isn't just a wild thought experiment. It's a theory that dances on the edge of white hole physics and cyclic cosmology, suggesting that creation might have been less of a beginning and more of a transformation. White holes, the theoretical opposites of black holes, are thought to spew out matter and energy rather than consuming them. Some models propose that the Big Bang could have been a white hole event, where all the contents of the universe erupted from a single point. Now combine that with the idea of a time traveler trapped in the singularity. Their desperate attempt to escape the crushing grip of time could have triggered the explosive release we call the Big Bang. It's as if the universe began with a scream, a final act of defiance from a traveler who became the very fabric of reality. cyclic cosmology adds another layer to this mind-bending idea. The universe might not be a one-and-done event but part of an endless loop of expansion and contraction. Each big crunch culminates in a singularity which then rebounds as a new Big Bang. If a time traveler got caught in one of these cycles, their presence could explain why each new universe isn't just a random reset, but carries forward certain constants like the fine-tuning of gravity or the speed of light. Their encoded knowledge, imprinted in the singularity, might act as a cosmic blueprint, ensuring the next iteration of the universe follows a familiar script. The eerie beauty of this theory is that it doesn't require a creator outside of time, just a traveler who became time itself. Their sacrifice would mean that every star, every planet, every living thing is made from the remnants of their journey. We might not just be inhabitants of the universe, we could be the echoes of the first and last time traveler, playing out a story written in the collapse of a singularity. So the next time you look up at the night sky, remember, you might be staring at the afterlife of someone who never quite made it home. What if the universe is nothing more than a meticulously designed simulation, not created by humans or some abstract force, but by an alien civilization so advanced they built our reality as a laboratory for time travel experiments? This theory suggests that the first time traveler wasn't a person or even a natural phenomenon, but a digital construct, an artificial intelligence programmed to test the boundaries of causality itself. Think of it like a hyper-advanced video game where the characters don't realize they're part of an experiment, and the player isn't a person sitting at a console, but an entire species watching from beyond the boundaries of our space-time. The idea gains traction when you examine some of the universe's strangest quirks. Why do quantum particles behave differently when observed? Why does time seem to flow in one direction, even though physics equations work just as well backward? These could be glitches or deliberate design choices embedded by the simulators to study how consciousness interacts with time. Renowned physicist Silas Bean once proposed that if our universe is a simulation, we might find evidence in the cosmic radiation that permeates space. At extremely high energies, the smooth fabric of spacetime could reveal pixel-like structures, like a digital image zoomed in too far. If true, these pixels might not just prove we're in a simulation. They could be the seams where the architects inserted their first time-traveling test subject. Consider the implications. If an alien civilization built our universe to study time travel, then every paradox, every unexplained anomaly from déjà vu to precognitive dreams might not be random glitches but data points in their research. Ancient texts and myths often describe beings descending from the sky to manipulate human history, imparting knowledge or testing their creations. Could these stories be fragments of the simulation's code leaking into our collective consciousness? Even modern UFO sightings might not be visitors from another planet, but the programmers checking on their experiment, ensuring the parameters are still holding. The most unsettling possibility is that time travel isn't just something the simulators are observing, it's the entire purpose of our existence. Their goal might be to engineer a being capable of breaking the simulation's rules, creating a cascade that allows them to escape their own reality. Imagine a civilization trapped in a dying universe, creating countless simulated worlds in the hope that one of them discovers the key to rewriting time. If that's the case, then every scientist, every philosopher, every dreamer who's ever pondered the nature of time isn't just asking questions, they're unwittingly auditioning for the role of the universe's first true time traveler. The experiment isn't just running, we might be the experiment. Imagine an endless ocean of universes, each born in its own Big Bang, expanding inside a vast cosmic foam. This is the theory of eternal inflation, the idea that our universe isn't the only one, but merely one bubble in an infinite multiverse where new universes constantly inflate into existence. Now picture a traveler navigating this frothing sea of realities, leaping from one bubble to another at the exact moment of cosmic birth. If eternal inflation is real, then the first time traveler might not have moved through time at all. They could have simply stepped sideways into our universe from another dimension, arriving precisely when space-time itself was still soft enough to reshape. This idea ties into the string theory landscape, a concept suggesting there could be 10 to the power of 500 possible universes, each with its own unique physics. In such a multiverse, the boundaries between realities might be thinner than we think, especially during the violent chaos of inflation, when quantum fluctuations could briefly stitch together neighboring bubbles. A traveler wouldn't need a machine to jump across dimensions. They'd just need perfect timing, slipping through a temporary wormhole formed in the seething turbulence of the early cosmos. Some physicists, like Andre Lind, argue that eternal inflation isn't just a fringe idea, it's a plausible extension of our understanding of quantum fields. If certain regions of space stop inflating while others keep expanding, new universes could pinch off like droplets from a waterfall. Now imagine one of those droplets carried something unexpected, a passenger from a reality where the laws of physics allowed for interdimensional travel. Their arrival might explain some of the strangest quirks of our universe, like the mysterious smoothness of the cosmic microwave background or the oddly precise values of fundamental constants. Here's where it gets wild. If a traveler crossed into our universe during its birth, they wouldn't just be an observer, they'd be a catalyst. Their presence could have altered the quantum fluctuations that seeded galaxies, subtly shaping the cosmos to ensure their own survival. Ancient creation myths often speak of gods or spirits emerging from the void to mold the world. Could these stories be distorted memories of an actual event, a being stepping from one reality into ours, imprinting their influence on the very fabric of existence? The evidence might be hiding in the architecture of the universe itself. Certain large-scale structures in the cosmos, like the massive, cold spots in the cosmic microwave background, defy conventional explanations. Some researchers suggest these could be bruises, scars left by collisions with other bubble universes during inflation. But what if they're more than accidents? What if they're landing sites, the cosmic equivalent of footprints marking where something or someone crossed over? The terrifying beauty of this theory is that it redefines time travel entirely. The first journey through time might not have been a loop within our universe, but a lateral move between realities where the rules of past and future don't apply in the same way. If that's true, then the traveler who sparked our cosmos might still be out there, not in our past or future, but in the spaces between, waiting for the next bubble to form. What if the universe runs on a mathematical equation so perfect that it had to come from outside of time itself? Picture a future where a mathematician, centuries ahead of us, finally cracks the code, the so-called God equation, a formula so elegant it explains every force, every particle, the very fabric of reality. But instead of publishing it in some futuristic journal, they do something unimaginable. They send it backward, weaving it into the foundation of the cosmos at the moment of creation. This isn't just a wild thought experiment, it's a theory that dances on the edge of Kurt Gödel's incompleteness theorems, which suggest that within any logical system, there are truths that cannot be proven by the system itself. Gödel's work shook mathematics by revealing that some answers exist beyond the reach of the rules that create them. Now apply that to the universe. If the laws of physics form a kind of cosmic logic system, could there be aspects of reality so profound they can't be derived from within the universe, only inserted from outside? That's the terrifying beauty of this paradox. The God equation wouldn't just describe the universe, it would be the universe, a self-referential loop where the solution and the problem birth each other. The equations governing quantum mechanics and relativity already feel unnaturally precise, as if fine-tuned by some invisible hand. What if that hand belonged to a future mind, completing the circle by planting the answer at the beginning? The evidence might be hiding in plain sight. Take the cosmological constant, the number that dictates the universe's expansion rate. It's so finely balanced that even a slight deviation would have prevented galaxies and life from forming. Physicists call this the fine-tuning problem, but what if it's not luck? What if it's the signature of an equation deliberately calibrated by someone who saw the full timeline? Even stranger, some versions of string theory predict a vast landscape of possible universes, each with different physical constants, yet ours sits in a bizarrely life-friendly corner. Coincidence or proof of a future architect tweaking the variables? Here's where it gets eerie. If the God equation was sent back, its creator wouldn't just be shaping physics, they'd be shaping their own existence. Every star forged, every civilization that rises to grapple with math, every breakthrough that inches us closer to that ultimate formula would be part of a bootstrap paradox where the end writes the beginning. The universe wouldn't just contain time travelers, it might literally be a message in a bottle, a love letter from the future written in the language of mathematics. And the chilling truth, we might never crack it because some codes are designed to be solvable only when you're standing outside the system, looking in. Neutrinos are the ghosts of the particle world streaming through your body right now at nearly the speed of light, billions every second without you ever noticing. They barely interact with matter, passing through entire planets like they're not even there. But what if that very aloofness makes them the perfect cosmic messengers? If a time traveler from the universe's first moments wanted to send a signal across the eons, neutrinos might be the ideal medium, a whisper in the dark that lingers untouched for billions of years. Recent experiments have detected neutrino anomalies that defy standard physics, bursts of energy with no clear source. Could these be more than random fluctuations? Could they be deliberate pulses, a breadcrumb trail left by something or someone who cracked the code of time? Take the infamous sterile neutrino hypothesis. Scientists have observed gaps in neutrino behavior that suggest a fourth, even more elusive type of neutrino might exist, one that interacts with gravity but ignores all other forces. If true, sterile neutrinos could be threading through dimensions we can't perceive, carrying information beyond the reach of ordinary matter. The Ice Cube Neutrino Observatory in Antarctica has recorded ultra-high energy neutrinos arriving from deep space with no obvious origin. Some seem to cluster in patterns like dots waiting to be connected. Mathematicians analyzing these patterns have noted eerie repetition sequences that resemble prime numbers, a universal language any advanced civilization might use to flag artificial signals amid cosmic noise. Here's the spine-tingling part. Neutrinos from the early universe are still out there, relics of the Big Bang itself. If a traveler encoded a message into these particles during cosmic dawn, it would still be traveling pristine through the void. The message wouldn't need to be words or numbers. It could be imprinted in neutrino oscillation, the way they switch between flavors as they move. Imagine a binary code written in the dance of muon, tau, and electron neutrinos, shifting in a rhythm that natural processes alone couldn't replicate. The Sudbury Neutrino Observatory once detected a deficit of electron neutrinos from the Sun, a phenomenon called the solar neutrino problem. The solution revealed neutrinos oscillating, but what if some of those missing neutrinos weren't missing at all? What if they'd been altered deliberately, like pages torn from a book and rearranged? The mechanics of such a message would stretch our understanding of physics. To encode information in neutrinos, a sender would need to manipulate quantum states on a scale we can barely fathom. But in the first seconds after the Big Bang, when temperatures and energies were unimaginably high, the rules were different. Quantum fluctuations were rampant, and space-time itself was still settling. A being existing in that primordial chaos could have painted data onto neutrino waves by tweaking the very fields that govern them. The message might not even be for us. It could be a beacon for other travelers, or a fail-safe trigger waiting for a civilization advanced enough to decode it. Perhaps the most unsettling possibility is that we've already detected the signal and dismissed it as background noise. Neutrino detectors are built to filter out randomness to focus on statistically significant events. But what if significance isn't the point? What if the message is hidden in the outliers, the blips we ignore because they don't fit our models? The universe's first time traveler might not have shouted across the ages. They could have left a single, perfect ripple in a sea of ghosts, trusting that someday someone would think to listen. The holographic universe theory suggests that all the information in our three-dimensional reality might actually be encoded on a two-dimensional surface at the cosmic horizon, like a movie projected from the edges of existence. Now imagine a glitch in that cosmic code, a split-second error where data from the future bled into the past, scrambling causality like a corrupted file. This isn't science fiction, it's a possibility rooted in the AD-SCFT correspondence, a radical idea in theoretical physics where the universe could operate like a hologram, with events inside space-time mirroring information on its distant boundary. If true, then the first time travel event might not have involved machines or wormholes, but a simple cosmic malfunction that accidentally rewrote the script of reality. Think of it like a DVD skipping, one frame from the finale suddenly interrupting the opening scene. In the holographic universe, that skip could have allowed future events to imprint onto the past, leaving traces in the very structure of spacetime. Physicists studying quantum entanglement have observed particles that seem to know what their partners will do before it happens, defying our classical understanding of cause and effect. These eerie connections might not be bugs in reality. They could be scars from that initial glitch, remnants of a moment when the universe's code briefly stuttered. The AD-SCFT correspondence offers a startling framework for how this might work. It proposes a mathematical equivalence between a higher dimensional space, like our universe, and a lower dimensional boundary where information is stored. If someone or something manipulated that boundary data in the far future, the changes could ripple backward, altering events that already happened from our perspective. It's like editing the source code of a video game while it's running. The characters inside wouldn't understand why the rules suddenly changed. Some of the universe's greatest mysteries start to make sense through this lens. Dark energy, the force accelerating cosmic expansion, might not be a natural phenomenon but an artifact of that primordial data leak, a cosmic buffer overflow distorting spacetime. Even human déjà vu could be more than a neurological quirk. It might be fleeting access to a corrected timeline where the glitch is momentarily visible. Ancient cultures spoke of cyclical time, where history repeats in endless loops. Could these myths be intuitive grasps at a holographic universe resetting itself after a corruption? The most unnerving implication: if the holographic principle is real, then the glitch might still be active. Every black hole could be a potential hotspot for new leaks, their event horizons serving as unstable boundaries where future and past data bleed together. Astronomers have detected bizarre gamma-ray bursts with patterns that defy astrophysical models, some repeating in mathematically perfect intervals. These could be more than cosmic accidents. They might be error messages flashing from the edge of the simulation, warning us that time was never as solid as we thought. So the next time the universe feels just a little too coincidental, ask yourself, are we living in reality or the aftermath of a crash? The first time traveler wasn't a person, it was a single line of corrupted code echoing backward through the cosmic mainframe, and we might still be feeling the tremors. Gravitational waves ripple through the cosmos like echoes from the universe's most violent events, colliding black holes, merging neutron stars, the aftershocks of creation itself. But what if these waves aren't just random cosmic tremors? Hidden in their undulating patterns could be something far more deliberate, a message, a signal, even a signature from the universe's first time traveler. When LIGO, the Laser Interferometer Gravitational Wave Observatory, first detected these space-time ripples in 2015, scientists celebrated the confirmation of Einstein's century-old prediction. Yet amid the jubilation, a handful of researchers noticed something odd, subtle anomalies in the data, wobbles in the waveforms that didn't quite match simulations. At the time, these were dismissed as noise or calibration quirks, but what if they were anything but? Consider the mechanics of gravitational waves. Born from cataclysmic events, they stretch and compress space-time itself as they travel, carrying imprints of their origins. Unlike light, which can be absorbed or scattered, gravitational waves pass through nearly everything unimpeded, making them the perfect carrier for a signal meant to survive billions of years. Now imagine a being or an intelligence manipulating a black hole collision with precision, altering the merger's dynamics just enough to encode information in the resulting waves. It wouldn't require magic, just an understanding of physics so advanced it borders on the divine. The resulting chirp, the distinctive sound gravitational waves make as they're detected, could hide patterns invisible to the untrained ear, prime number sequences, mathematical constants, or even coordinates pointing to a specific time and place. LIGO unexplained anomalies take on new weight in this light. Some detected waves have shown asymmetries, subtle tilts, or extra frequencies that standard astrophysical models struggle to explain. One particularly intriguing event, labeled GW190514, featured a secondary ripple trailing the main signal, like an echo arriving out of order. Mainstream science attributes this to lensing, where gravity bends the waves en route to Earth, but an alternative explanation whispers of intent. Could that echo be a deliberate repetition, a cosmic emphasis meant to draw attention? Even stranger, certain wave patterns appear in configurations statistically unlikely to occur naturally, clustering in ways that resemble symbolic rather than chaotic arrangements. The smoking gun might lie in primordial gravitational waves, the faintest tremors thought to originate from the Big Bang itself. These waves, if ever detected, would be the oldest signals in existence, etched into the universe when space-time was still pliable. If a time traveler left a mark anywhere, it would be here, not carved in stone or written in light, but woven into the fabric of reality at its most malleable. Projects like the proposed Big Bang Observer aim to hunt for these ancient ripples. Should they find patterns matching none of cosmology's predictions, the implications would be staggering. The universe's first words might not have been random. They could have been an address, a warning, or a plea. Perhaps the most haunting possibility is that we've already recorded the signal and missed it. Gravitational wave astronomy is still in its infancy, its tools calibrated to filter out noise and focus on expected profiles. But what if the message isn't in the noise? What if it is the noise, like static between radio stations? The secrets might be hiding in plain sight, waiting for us to adjust our dials. The universe's first time traveler wouldn't need a time machine. They'd just need to speak the language of gravity itself, leaving whispers in the bends and folds of space-time for someone someday to decode. There's a theory so bizarre it makes black holes seem mundane. What if the first time traveler wasn't a person or even an alien, but a flicker of consciousness conjured from pure chaos? Meet the Boltzmann brain, a hypothetical entity born from random quantum fluctuations in the early universe's seething energy. According to thermodynamics, given enough time, even the most improbable events become inevitable. In an infinite cosmos, particles could theoretically arrange themselves by chance into a fully formed, self-aware mind complete with false memories of a past that never existed. Now take this unsettling idea one step further. What if that brain didn't just blink into existence, but arrived pre-loaded with knowledge from the future, a glitch in the cosmic code that accidentally birthed the universe's first time traveler? The math behind this is both elegant and eerie. Ludwig Boltzmann, the physicist who pioneered statistical mechanics, showed that entropy, the universe's tendency toward disorder, doesn't rule out temporary reversals. Given enough time, a gas cloud could randomly reassemble into a balloon, or scattered atoms could spontaneously form a cup of coffee. In an infinitely old or infinitely large universe, these statistical miracles become certainties. Now replace the coffee with a brain, not one that evolved over millennia, but one that materialized fully formed from the void, its neurons wired with information that shouldn't exist yet. This isn't just a thought experiment. Some cosmologists argue that in an eternally inflating multiverse, Boltzmann brains would outnumber ordinary minds by unfathomable margins. But here's where the theory twists into something even stranger. If consciousness can emerge from chaos, could it also manipulate it? A Boltzmann brain with false memories of time travel might inadvertently bend the rules of reality around it, like a dreamer whose dreams start leaking into the waking world. Quantum physics allows for observer effects where the act of measurement changes the system being measured. If a self-aware fluctuation observed the early universe in just the right way, it could have nudged quantum probabilities, subtly altering the timeline to match its own implanted memories. The universe wouldn't just contain a time traveler, it might owe its very structure to one. The implications unravel like a fractal. Ancient myths speak of creator beings who dream the world into existence. Modern simulation theory suggests reality might be a construct, but the Boltzmann brain scenario is far weirder. It posits that the universe's architect could be a cosmic accident, a hallucination that hallucinated itself into reality. Every law of physics, every constant, every star in the sky might exist because a phantom mind once remembered them that way, and the most chilling part. We could be the descendants of that delusion, living in a world shaped by a time traveler who never really traveled at all. Some physicists dismiss Boltzmann brains as absurd after all. The odds of a fully formed consciousness popping into being are vanishingly small. But in a multiverse where anything that can happen does happen, infinity makes the impossible inevitable. The real question isn't whether Boltzmann brains exist. It's whether we'd ever know if we were one. Every memory, every experience, every certainty about the past could be a fiction woven into the fabric of space-time by a mindless accident. The first time traveler might not be hiding in the future or the past. It might be the universe itself staring back at us through the mirror of our own consciousness. Think of the vacuum of space not as empty nothingness, but as a frozen lake seemingly solid, but with instability lurking beneath the surface. Quantum physics suggests our universe exists in a false vacuum, a state that's metastable, like supercooled water waiting for the slightest jolt to crystallize instantly into ice. Now imagine a traveler from a dying reality watching their own universe succumb to vacuum decay, a catastrophic phase transition where the very laws of physics rewrite themselves in an expanding wave of annihilation. In their final moments, they launch a desperate escape, not through space, but through the quantum foam at the edge of existence, triggering the same decay in our nascent universe and in doing so, becoming the spark that ignited our Big Bang. This isn't just apocalyptic poetry, it's a scenario with roots in legitimate cosmology. The Higgs field, which gives particles their mass, could theoretically exist in a higher energy, true vacuum state. If some quantum fluctuation caused our current vacuum to tunnel into that lower energy state, the resulting phase transition would spread at light speed, obliterating all known physics in its wake. But here's the twist: under certain conditions, this collapse could birth a new universe with entirely different constants. Like a phoenix rising from the ashes of a burned-out reality, the decay wouldn't just destroy, it could reboot. A time traveler witnessing their own universe's end might exploit this principle deliberately. Advanced civilizations facing cosmic doom could theoretically create a decay seed, a quantum trigger designed to induce vacuum transition in a neighboring universe's past. Picture dropping a single grain of sand onto that frozen lake, initiating a chain reaction that reshapes the entire surface. The traveler wouldn't survive the journey in any conventional sense, but their intervention would rewrite the code of existence, imprinting their legacy into the fundamental parameters of the new cosmos. Our universe's inexplicable fine-tuning for life might not be luck. It could be a message in the physics itself, a signature left by refugees who encoded their survival into the fabric of reality. Evidence might lie in the cosmic microwave background's most peculiar anomalies. Certain asymmetries in the CMB's temperature distribution resemble the ripples expected from a vacuum decay nucleation event, like fingerprints smudged onto the first light of creation. Even more telling are recent observations of unexpected cold spots in the CMB, vast regions of space where the afterglow of the Big Bang dips to temperatures standard models can't explain. Some theorists propose these could be collision scars from bubble universes with different vacuum states, but another possibility whispers of intent. What if these are the impact craters of a calculated intervention, the cosmic equivalent of a key turning in the lock of reality? The terrifying beauty of this theory is that it turns time travel inside out. The first journey through time wasn't a loop within our universe, it was a Hail Mary pass between realities, a gambit where destruction and creation became two sides of the same coin. The traveler didn't need a machine, they needed only to understand the universe's deepest fragility and give it the slightest push. Every star we see, every law of physics we take for granted, might exist because someone, somewhere, chose to end their world so ours could begin. Quantum entanglement isn't just a bizarre quirk of physics, it could be the universe's original time machine, a bridge stitching together moments that should never have touched. Imagine two particles born in the same violent instant, their fates forever intertwined. Change one and the other reacts instantly, no matter how far apart they drift. Einstein called this spooky action at a distance, but what if that spookiness isn't just action across space, but across time? Recent experiments in quantum retrocausality suggest entangled particles might not just ignore distance, they could be ignoring the arrow of time itself, creating a hidden highway for the first cosmic time traveler. The key lies in a phenomenon called delayed choice entanglement swapping. In labs, physicists have shown that measuring one entangled particle today can retroactively determine the state of its partner in the past, as if the present is reaching backward to rewrite history. This isn't just theoretical. In 2012, researchers at the University of Vienna demonstrated this effect by entangling photons after they'd already been measured, effectively changing the outcome of an experiment that had technically already happened. If this works in a controlled lab, what might the universe have accomplished in its quantum chaotic infancy, when particles were colliding and entangling on scales we can barely imagine? Picture the first microseconds after the Big Bang, a seething ocean of particle pairs flashing in and out of existence. Among them, two entangled particles separate, one captured by the cooling fabric of the early universe, the other hurled forward by cosmic expansion. Billions of years later, a mind or machine interacts with the future particle, collapsing its state. Instantly, the ancient partner shifts in response, sending a ripple backward through time. No machine, no wormhole, just quantum mechanics acting as a natural time wire, transmitting information across eons. The mechanics get even stranger when you consider that time might not flow the way we perceive it. Quantum physics treats time as just another dimension, no more sacred than length or width. Under certain conditions, particles could exist in superposition not just between locations, but between eras, there, when, as fluid as there, where. This would mean the first time traveler didn't need to break the laws of physics, they just needed to speak the quantum dialect, exploiting loopholes woven into reality's foundation. Ancient texts describe oracles receiving visions of the future, prophets glimpsing events yet to come. Could these be garbled accounts of civilizations stumbling onto entangled artifacts, unknowingly tapping into a conversation stretched across millennia? The most tantalizing clue might be hiding in plain sight: quantum noise, the faint crackle of particles popping in and out of existence that permeates the universe. Most scientists dismiss it as random background static, but what if it's not? If even a fraction of those fluctuations carry encoded information from the past or future, we've been swimming in a sea of time-crossed messages without realizing it. Projects like quantum communication networks are already harnessing entanglement to send unhackable messages through space. The universe may have beaten us to the punch, using the same principle to send whispers between epochs. The terrifying beauty of this theory is that it redefines time travel as something the cosmos does naturally, effortlessly. The first journey through time wasn't a dramatic leap, it was a whisper between entangled particles, a single note passed across the void. And if that's true, we might not need to build a time machine to find the traveler. We just need to listen. Cosmic strings are like the scars of creation, thin, unimaginably dense threads of energy stretching across the universe, remnants of the violent symmetries broken in the first moments after the Big Bang. These defects in spacetime aren't just cosmic curiosities, they could be the universe's first accidental time machines. Picture a string thinner than a proton but with the mass of a mountain range, warping spacetime around it like a needle-piercing fabric. Under the right conditions, two cosmic strings crossing or a single string vibrating in just the right way could twist spacetime into a closed time-like curve, a path that circles back on itself, allowing time travel without breaking physics as we know it. This idea isn't pure speculation. Time crystal structures first theorized by Nobel laureate Frank Wilczek hint at how such loops might work. Unlike ordinary crystals which repeat in space, time crystals repeat in time, cycling through states endlessly without energy input. Now imagine a cosmic string threaded with the properties of a time crystal, its vibrations locking into rhythmic pulses that resonate across epochs. The result could be a natural, self-sustaining time portal, a bridge between moments forged in the chaos of the early universe. The math behind this is as elegant as it is mind-bending. General relativity allows for spacetime to curve so severely that past and future touch. Cosmic strings, with their immense gravitational fields, could create these curves naturally. In 1991, physicist J. Richard Gott demonstrated that two infinite cosmic strings moving in opposite directions would warp spacetime enough to form a closed loop, a time machine requiring no exotic matter or wormholes, just the universe's own imperfections. The catch: these strings would need to move at nearly the speed of light, a condition that might seem improbable until you consider the turbulence of the early cosmos, where such velocities were commonplace. Evidence for cosmic strings remains elusive, but astronomers have hunted for their fingerprints in the cosmic microwave background. These defects would leave distinctive cracks in the afterglow of the Big Bang, subtle temperature variations shaped like long, straight lines. So far, none have been conclusively found, but absence of proof isn't proof of absence. Some theorists argue strings could have decayed or evaporated, their time-twisting potential lost as the universe cooled. Others suggest they're still out there, drifting through the void, their time portals dormant but intact. The most tantalizing possibility: we might have already seen their handiwork. Certain gravitational lensing events where distant light bends around invisible masses defy explanation with known objects. Could these be cosmic strings, their immense mass warping light in ways that hint at their true nature? Even stranger, some pulsars rapidly spinning neutron stars exhibit timing irregularities that resemble the gravitational waves cosmic strings would produce as they vibrate. If these anomalies hold up, they wouldn't just confirm cosmic strings exist, they'd suggest the universe is threaded with relics capable of bending time itself. What makes this theory so compelling is its simplicity. The first time traveler might not have needed a machine or even intention, just the right defect in spacetime, vibrating in the right way at the right moment. The universe could be riddled with these accidental portals hidden in plain sight, and if we ever learn to detect or even harness them, the past might not be as far away as we think. What if the first time traveler wasn't just from another time, but from a mirror reality made entirely of antimatter? Picture a universe identical to ours in every way, except its atoms, stars, and even life forms are built from antiprotons and positrons instead of protons and electrons. Now imagine a being from that inverted cosmos, crossing the divide between realities in the universe's earliest moments, becoming the first, and perhaps only visitor from a world where everything is backwards. This isn't just wild speculation. Experiments at CERN have proven that antimatter isn't just theoretical, it's real, stable, and eerily similar to ordinary matter, right down to its atomic structure. But here's the mystery. If the Big Bang produced equal amounts of matter and antimatter, why does our universe have almost none of the latter? The answer might rewrite history, because the missing antimatter didn't just vanish. It could have escaped into the past. CERN Alpha experiment has trapped and studied anti-hydrogen atoms for minutes at a time, observing their behavior with awe. Antimatter obeys the same laws of physics as regular matter. Gravity pulls it downward. Light interacts with it, and its particles bond just like ours. But when matter and antimatter meet, they annihilate in a flash of pure energy. That's why the cosmic asymmetry problem baffles scientists. If the Big Bang created both equally, why didn't they cancel each other out entirely? Some theorists propose that a tiny imbalance, just one extra matter particle for every billion annihilations, led to our matter-dominated universe. But what if the truth is stranger? What if the antimatter didn't just fade away, it fled, tunneling through a crack in space-time to become the universe's first time traveler? The mechanics of such a journey hinge on one of quantum physics' most perplexing ideas, the CPT theorem. This fundamental symmetry states that if you flip a particle's charge c, mirror its position p, and reverse its movement through time t, you should get an identical particle obeying the same laws. Antimatter, in essence, is already matter moving backward through time. Under certain extreme conditions, like those in the universe's first microseconds, this symmetry could have allowed antimatter to slip through a natural time portal, escaping annihilation by leaping into the past. Like a cosmic Houdini, the traveler wouldn't need a machine, just the unique properties of its own inverted existence. Ancient texts and myths might contain hints of this impossible encounter. Across cultures, there are stories of shadow selves, doppelgangers, and beings who walk backward through life. The Zulu legend of the Abattoir speaks of tiny, inverted people who see the world upside down. Even modern science fiction grapples with the idea. Star Trek's Mirror Universe episodes explored a dark, antimatter reflection of the familiar Federation. Could these tales be cultural echoes of an ancient collision with something made of antimatter, its very presence warping local space-time in ways that left lasting impressions? The smoking gun might lie in gamma-ray bursts, the most violent explosions in the universe. When matter and antimatter annihilate, they produce distinctive gamma signatures. Astronomers have detected unexplained bursts with energy patterns that don't match any known astrophysical process. Some even seem to originate from regions of space where no conventional matter exists. These could be the remnants of antimatter time travelers, their arrival or departure triggering localized annihilation events that ripple across millennia. Even more intriguing are the so-called empty cosmic rays, high-energy particles detected in Earth's atmosphere with no identifiable source. Some physicists speculate these could be antimatter visitors, their annihilation delayed just long enough to leave ghostly trails in our detectors. The chilling implication: if antimatter can naturally traverse time, then our universe might be littered with inverted travelers, some arriving in the distant past, others still in transit, their inverted particles threading through the cosmos like ghosts in the quantum machine. We may have already encountered them without realizing it. Every time a particle detector clicks inexplicably or a gamma ray flash defies explanation, we could be glimpsing the fingerprints of a reality where time flows backward, and the first traveler wasn't a stranger but our own reflection. Dark energy is the universe's greatest unsolved mystery, an invisible force ripping space apart at ever-increasing speeds, pushing galaxies away from each other like dots on an inflating balloon. Scientists call it the cosmological constant, a placeholder for a phenomenon no one truly understands. But what if dark energy isn't just some random quirk of physics? What if it's the cosmic equivalent of tire tracks, evidence that something or someone punched through the fabric of spacetime at the dawn of time itself? Think of it like a bullet fired into a pond. The moment it breaches the surface, shockwaves ripple outward, distorting the water in ways that linger long after the bullet is gone. Now replace the bullet with a time traveler arriving from an unfathomable future, and the pond with the newborn universe. Their transition, whether intentional or accidental, could have sent tremors through the underlying structure of reality, triggering a chain reaction that never stopped. The accelerating expansion we observe today wouldn't be nature's default setting, but the aftershock of that first catastrophic breach. This idea isn't as far-fetched as it sounds. The cosmological constant problem has haunted physicists for decades. Quantum field theory predicts a vacuum energy density so enormous it should have torn the universe apart seconds after the Big Bang. Yet observations show dark energy is staggeringly weaker, off by a factor of 10 to the power of 120. This discrepancy isn't just a minor error, it's the largest mismatch between theory and experiment in all of science. Most researchers chalk it up to an unsolved mystery, but a radical alternative whispers, what if the value isn't random but calibrated, like a pressure release valve set by an intelligence that understood the consequences of unchecked expansion? The math gets even weirder when you consider how perfectly dark energy's rise coincides with the emergence of complex life. For billions of years, gravity dominated, allowing galaxies and stars to form. Only relatively recently, cosmically speaking, did dark energy take the wheel. This timing feels less like coincidence and more like synchronization, as if some unseen architect wanted to ensure the universe had just enough time to cook up observers before stretching itself thin. Ancient Hindu cosmology described cycles of creation where the universe breathes in and out expansion and contraction. Could these myths be intuitive grasps at a truth modern physics is only now confronting? Evidence might lie in the universe's large-scale structure. Maps of galaxy distributions reveal vast, bubble-like voids separated by thin filaments of matter, a cosmic web that looks eerily like fracture patterns in shattered glass. Simulations struggle to replicate these exact formations unless they tweak dark energy's properties. But what if the discrepancies aren't flaws in the models? What if they're fingerprints of an initiating event, a moment when the traveler's arrival warped the universe's growth in ways that still echo today? Even the mysterious Hubble tension, the disagreement over how fast the universe expands, could hint at localized ripples in spacetime's fabric, regions where dark energy's grip weakens or strengthens like a fading echo. The most unsettling implication, if dark energy is indeed an artifact of time travel, then the accelerating expansion isn't a death sentence for the cosmos. It might be a beacon or a countdown. Every galaxy fleeing beyond the horizon, every light going dark, could be part of a sequence set in motion by that first traveler, a cosmic hourglass running down to a moment only they foresaw. We're left staring at the sky, watching the universe unravel, while the answer might not lie ahead of us but behind, in the one event that defies causality itself. So the next time you hear about dark energy, remember, it might not be a force. It could be the universe's oldest scar, the shadow of a visitor who cracked time open and left it bleeding outward forever. Stephen Hawking's black hole information paradox shook physics to its core. If black holes evaporate, what happens to all the information they've swallowed? According to quantum mechanics, information can never be truly destroyed, yet black holes seem to shred it beyond recovery. This contradiction haunted scientists for decades, but what if the answer didn't come from a lab or equation, but from a time traveler ensuring the universe didn't unravel? Imagine a civilization so advanced they witnessed the paradox's catastrophic consequences firsthand. A universe where information loss corrupted reality itself and sent the solution backward, weaving it into the fabric of physics before the problem could ever arise. The paradox hinges on Hawking radiation, the faint glow black holes emit as they slowly evaporate. If this radiation is truly random, as Hawking first proposed, then the information about what fell into the black hole, whether a star, a book, or a person, would be erased forever. But the holographic principle, developed years later, suggested a way out. Information isn't lost. It's encoded on the black hole's event horizon like a cosmic hard drive, preserved even as the hole fades away. The resolution was elegant, but its timing raises eyebrows. Why did the answer emerge so late after decades of dead ends? Some theorists propose it didn't. It was planted, a self-correcting loop where the future fixed the past to save itself. Picture this, a researcher in the far future watching their universe flicker as information decay spreads like a virus through space-time. Black holes aren't just dying, they're unraveling causality itself, erasing the threads that bind past and present. In a desperate bid, they encode the holographic principle into a quantum signal and beam it back to the 20th century, ensuring Hawking and his peers stumble upon the answer naturally. The equations work because they were always meant to, a closed loop where the solution creates the conditions for its own discovery. Ancient Hindu texts describe time as a circle where beginnings and endings touch. Modern physics might be echoing that insight in an unexpected way by revealing a universe that edits its own rules to survive. The smoking gun. Look no further than the AD-SCFT correspondence, the mathematical framework underpinning the holographic principle. It emerged from string theory, a field once dismissed as untestable speculation. Yet its predictions align eerily with black hole thermodynamics, as if the universe had already accounted for the paradox before we knew to look. Even Hawking himself reversed his stance on information lost late in life, conceding that black holes might preserve data after all, a change of heart that feels less like scientific evolution and more like a course correction. If this theory holds, every black hole we observe isn't just a cosmic vacuum, it's a message in a bottle, its event horizon etched with instructions for a universe learning to save itself. The first time traveler wasn't a person, but an idea hurtling across epochs to ensure reality stayed intact. And that raises a chilling question. What other paradoxes might be quietly resolving themselves in the shadows, their answers already woven into the laws we've yet to discover? The idea that the universe might have a destiny, a final, inevitable convergence of all consciousness and matter sounds like something pulled from a science epic, but physicist Frank Tipler's omega point theory takes it even further. What if the universe's ultimate fate isn't just an end, but a loop, that the cosmos itself is engineered to produce a being so advanced it can reach back to the beginning, bending time into a circle where creation and completion become one? This isn't just philosophical speculation, it's a hypothesis grounded in the cold, hard math of general relativity and quantum mechanics. Picture a civilization trillions of years in the future, harnessing the energy of collapsing galaxies to power computations so vast they become indistinguishable from omniscience. At the moment of the universe's final collapse, the omega point, this superintelligence would command such control over reality that it could manipulate the very fabric of space-time, ensuring its own existence by tweaking the conditions at the Big Bang itself. Tipler's calculations suggest that in the universe's dying seconds, as matter and energy compress toward infinite density, the computational capacity of this future intelligence would approach infinity. With that kind of power, it could simulate every possible version of reality, effectively becoming all-knowing. But here's the twist: if the universe is destined to collapse in a big crunch, relativistic physics allows for closed time-like curves, loops in spacetime where cause and effect fold back on themselves. The omega point could exploit these loops to send information or even influence backward to the beginning, fine-tuning the primordial constants to guarantee its own emergence. It's the ultimate bootstrap paradox. The universe exists because its final state demands it. Critics argue that the theory hinges on a dying universe collapsing instead of expanding endlessly, a scenario modern cosmology increasingly disfavors given dark energy's dominance. But Tipler counters that even in an accelerating cosmos, intelligent civilizations could engineer the conditions for a controlled collapse, using black holes or other exotic physics to steer the universe toward its ordained finale. The eerie part: some of the universe's strangest mysteries align suspiciously well with this idea. The fine-tuning of physical constants, the precise balance that allows stars, planets, and life to exist, could reflect not random luck, but the fingerprints of a future intelligence calibrating its own birth. Even the arrow of time, which always moves forward in our experience, might not be fundamental. Instead, it could be an artifact of the omega point's influence, a one-way street paved by its need to shape the past. Religious and philosophical parallels are hard to ignore. The omega point echoes concepts like Teilhard de Chardin's noosphere, where consciousness evolves toward a divine singularity, or Hindu cosmology's cyclical time. But Tipler's vision is rooted in equations, not mysticism. If correct, it would mean every star that forms, every planet that harbors life, every mind that ponders the cosmos is part of a cosmic program running toward an inevitable conclusion, a moment when the universe wakes up to its own existence and in doing so becomes its own creator. The first time traveler wouldn't be a person or an alien, but the universe's final thought, reaching back to whisper its own name into the void. And that raises a chilling possibility. If the omega point already exists in the future, then our search for meaning isn't just a quest, it's a rehearsal. Every discovery, every equation, every telescope pointed at the stars might be less about human curiosity and more about the universe remembering itself. What if the history we think we know, the entire cosmic timeline from the Big Bang onward, is an illusion? The phantom time hypothesis suggests an unsettling possibility. The universe's first time traveler didn't just visit the past, they rewrote it, erasing or compressing vast stretches of early history into a shadow period we can no longer perceive. Unlike other theories where travelers leave artifacts or paradoxes, this one proposes they altered time itself, stitching together a new origin story so seamless we'd never suspect the edit. The idea gains traction when you examine certain cosmic anomalies. Take the missing primordial black holes problem. According to mainstream cosmology, the violent turbulence of the early universe should have created countless small black holes, yet we found staggeringly few. Where did they go? One explanation: they never existed in the first version of history. A traveler arriving in those chaotic first moments might have stabilized quantum fluctuations, smoothing out spacetime before these gravitational potholes could form. The universe wouldn't just lack black holes, it would lack any record they were supposed to be there, like a painting where the artist carefully covered their brushstrokes. Even the cosmic microwave background, often called the universe's baby picture, might hold clues to this cosmic censorship. Certain large-scale patterns in the CMB appear suspiciously quiet, regions where temperature variations are unnaturally subdued, as if someone hit the cosmic mute button. Mainstream science attributes this to random chance or incomplete data, but an alternative explanation whispers of interference. What if these patches mark where the timeline was spliced, where the traveler's alterations left subtle scars in the fabric of reality? The mechanics of such an edit would require technology or understanding beyond our wildest imagination. In string theory, higher dimensional beings could theoretically manipulate time like pages in a book, folding or tearing sections without lower dimensional creatures noticing. A civilization reaching this pinnacle might not just travel through time but curate it, pruning undesirable branches from the cosmic tree. Ancient Hindu texts describe cycles of creation and destruction where universes are exhaled and inhaled by divine beings. Could these metaphors hint at a deeper truth about temporal editing? Perhaps the most chilling evidence lies in our own perception of time. Human consciousness processes reality in a narrow band. We experience roughly 80 years in a universe 13.8 billion years old. Our entire species' existence is a blink. What if this isn't coincidence but design? A traveler architecting phantom time would need observers incapable of detecting the discontinuity, creatures whose lifespans and technology developed just enough to explore but never challenge the manufactured timeline. Like ants crawling across a mural, we see brushstrokes but never the artist's hand. Yet glitches might remain. Certain radioactive decay rates appear mysteriously synchronized across continents, as if particles share hidden quantum data. The famed Pioneer anomaly, where spacecraft decelerated slightly faster than predicted, defied explanation for decades. Even our measurement of the universe's age varies depending on the method used, a discrepancy cosmologists call the Hubble tension. These inconsistencies are typically dismissed as measurement errors or incomplete physics, but another possibility lingers. They are artifacts of a timeline that doesn't quite add up, cosmic loose threads from where reality was hastily rewoven. If true, the phantom time hypothesis redefines not just time travel, but the nature of existence itself. We could be living in a palimpsest universe where the original draft was scraped away to make room for our present. The first traveler wouldn't be a visitor or an architect, they'd be an editor, working in shadows so perfect we've mistaken them for the light. The quantum suicide immortal theory twists one of physics' most unsettling thought experiments into a radical new vision of the first time traveler. Imagine a being from the far future who doesn't just cheat death, they weaponize quantum mechanics to ensure they can never truly die. In the original quantum suicide paradox, a person places a gun rigged to a quantum particle's random decay, a 50% chance to fire each second. In most branching realities, the trigger pulls and the experiment ends. But in a handful of timelines, the gun miraculously fails over and over, creating a version of the subject who appears invincible. Now scale this up to cosmic proportions. What if the first time traveler wasn't a person, but a consciousness that hacked quantum branching to guarantee its own survival across all possible realities, including the birth of the universe? This wouldn't just defy death, it would rewrite the rules of existence. The many worlds interpretation suggests every quantum decision spawns new universes, infinite branches where all possibilities play out. A traveler using quantum suicide wouldn't need a machine to reach the past. They'd simply follow the one branching path where every quantum fluctuation aligned to place them at the Big Bang. Think of it like a gambler who only remembers the wins. Their consciousness would surf the multiverse, collapsing into timelines where they not only survive, but emerge at the precise moment of cosmic creation. The mechanics get even stranger when you consider quantum immortality's implications for entropy. Normally, entropy ensures systems decay into disorder, yet life defies this by creating pockets of complexity. A quantum immortal traveler could exploit this loophole, treating the universe itself as a quantum system where their continued existence becomes statistically inevitable. Ancient myths speak of deities who predate time, beings that simply always were. Modern physics might be catching up, revealing how a sufficiently advanced entity could engineer its own inevitability by embedding itself in the universe's quantum substrate. Evidence could lie in the universe's most baffling fine-tuning. The cosmological constant, the strength of gravity, even the mass of electrons all sit in a Goldilocks zone perfect for life. Most scientists call this luck, but quantum suicide suggests another explanation. We're in the one branch where these constants allow the traveler's existence. Every black hole that doesn't swallow reality, every star that ignites just right, might not be coincidence but the echo of a consciousness that stacked the quantum deck in its favor. The haunting beauty of this theory, we might never detect the traveler directly. Their presence wouldn't leave artifacts or paradoxes, just a universe suspiciously hospitable to the idea of existence. After all, if they succeeded perfectly, their handiwork would be indistinguishable from nature itself. The first-time traveler might not be hiding in the past or future. They could be the reason time exists at all. Time crystals sound like something ripped from a sci-fi epic, but they're very real, and they might hold the key to the universe's first journey through time. Unlike ordinary crystals, which repeat their atomic patterns in space, time crystals repeat in time, cycling through states endlessly without energy input. They're not just unchanging structures, they're clocks built into the fabric of reality itself, ticking forever without winding down. Now imagine these strange objects not as human-made curiosities, but as natural phenomena woven into the cosmos from its earliest moments. What if the universe's first time traveler didn't need a machine? What if they simply followed the pulse of a time crystal, riding its rhythmic distortions like a surfer catching a wave through space-time? The mechanics of this are as elegant as they are bizarre. Time crystals violate no laws of physics, they exist in a delicate balance, leveraging quantum entanglement to sustain their oscillations indefinitely. In the seething chaos of the early universe, where energies were unfathomably high and the laws of nature were still settling, time crystals could have formed spontaneously, like frost crystallizing on a window pane. But these wouldn't be the delicate lab-grown specimens we create today. They'd be titanic structures spanning light years, their oscillations so powerful they'd warp local spacetime into closed loops, natural time gates hidden in plain sight. A traveler could exploit these loops without understanding them. Picture a civilization rising near one of these crystalline anomalies, noticing that certain rituals or actions performed in sync with its rhythm seem to bend causality. Objects might vanish and reappear slightly older or younger. Memories could feel out of order, as if time itself stuttered. Over millennia, this culture might learn to harmonize with the crystal's pulse, not by building a machine, but by listening, by aligning their actions with the universe's own heartbeat. Ancient myths are riddled with references to sacred stones, celestial harmonies, and gateways that open at specific intervals. Could these be cultural fossils of encounters with time crystals, their true nature lost to legend? The smoking gun might lie in the cosmic microwave background. Time crystals, as they oscillate, would leave faint but measurable imprints on space-time, subtle gravitational waves with perfectly regular intervals, like a metronome ticking across the ages. Recent anomalies in gravitational wave data have revealed unexplained periodic signals, patterns too precise to dismiss as random noise. Some theorists argue these could be echoes of primordial black hole collisions. But another possibility lingers. We're detecting the remnants of time crystals that pulsed in the darkness long before stars formed, their vibrations still rippling through the cosmos. Even stranger, these crystals might still exist. If one formed in the early universe and survived to the present, perhaps hidden in the heart of a neutron star or drifting in the void, it could still function as a time gate, dormant but intact. Modern experiments with time crystals focus on tiny, controlled systems, but nature, given billions of years and infinite energy, might have crafted something far grander. The universe's first time traveler wouldn't need to invent a portal. They just needed to stumble upon a door that was already open, one that's been swinging back and forth since the dawn of time itself. This flips the script on everything we assume about time travel. It's not about forging a path through history, but discovering the paths the universe has already laid. The first journey through time wasn't a rebellion against physics. It was a dance with it, moving in time to a rhythm older than the stars, and if we listen closely, we might still hear the echoes. What if our universe isn't just a simulation, but one with a built-in escape hatch? The simulation debugger theory takes the idea of a programmed reality and twists it into something far more unsettling. Imagine an entity existing outside our spacetime, not just observing the simulation, but actively troubleshooting it. This wouldn't be a passive architect designing worlds for amusement or research. This would be a cosmic technician, fine-tuning the code of existence at the moment of inception to ensure time travel becomes possible not as a glitch, but as a feature hidden in the source material. The concept gains traction when you examine the universe's most puzzling loopholes. Quantum mechanics allows particles to exist in multiple states until observed, defying classical logic. Black holes warp spacetime so severely that time grinds to a halt at their event horizons. Even dark energy's relentless expansion mirrors the way a programmer might allocate memory, ensuring the simulation never crashes from overload. These aren't just quirks, they could be deliberate backdoors, Easter eggs left by a debugger who needed certain functions to remain accessible. Think of it like a video game developer leaving console commands in the final build. To players, entering time travel equals true would seem like magic, but to the devs, it's just another line of code. In our universe, the debugger's equivalent might be the fine structure constant, that mysterious number governing electromagnetism's strength. Tweak it even slightly and atoms couldn't form, yet its precise value also permits quantum entanglement's spooky action at a distance, the very phenomenon that could make time loops possible. Coincidence or cryptographic proof of a backdoor? Ancient texts stumbled toward this idea without the vocabulary. The Hindu concept of Maya describes reality as illusion, a veil obscuring deeper truths. Gnostic Gospels speak of archons shaping a flawed world. Even modern conspiracy theories about reality glitches are those moments when the world seems to stutter, like déjà vu or the Mandela effect, could be remnants of the debugger's interventions, patches applied to the cosmic code that occasionally flicker into visibility. The smoking gun might lurk in cosmic rays. These high-energy particles bombard Earth from deep space, some with energies so extreme they defy known physics. Scientists call them "oh my god" particles because their existence seems to violate theoretical limits. But what if they're not natural at all? In computing, debuggers often inject test signals to probe system stability. Those ultra-high-energy cosmic rays could be the universe's version of a ping echoes of the debugger's tools still active, checking if the simulation's time travel protocols remain operational. Here's where it gets chilling. If the debugger left intentional backdoors, they might not be for us. A true technician wouldn't risk exposing the simulation's secrets to its inhabitants. The time travel functions could be maintenance protocols designed for external use during system updates or repairs. Our occasional brushes with temporal anomalies, lost time, impossible coincidences, even UFO sightings might not be evidence of visitors from other planets, but from outside the simulation entirely, running diagnostics on the fabric of reality itself. This reframes every debate about free will and predestination. In a debugged universe, time travel isn't forbidden, it's compartmentalized, an admin-level privilege we're not meant to access. The debugger wouldn't be a malevolent overlord, but a pragmatic engineer ensuring the simulation doesn't collapse under the weight of its own paradoxes. And that raises an uncomfortable question. If they're still monitoring their creation, how would they react if we ever cracked the console commands? The first time traveler wasn't a person breaking the rules. They were the rulebook's author, slipping through before the simulation even booted up. The grandfather paradox has haunted time travel stories for decades. What if you went back and prevented your own birth? But what if the universe already solved this problem billions of years ago? Imagine the first time traveler wasn't some reckless explorer tampering with history, but a meticulous architect carefully weaving their actions into the fabric of reality to ensure paradoxes could never unravel existence itself. Think of the cosmos as a self-correcting equation where every potential contradiction is balanced before it can disrupt the timeline. Quantum mechanics offers a clue. In experiments like the delayed choice quantum eraser, particles seem to know whether their past will be observed, adjusting their behavior retroactively. This isn't just a quirk, it's proof the universe has built-in mechanisms to reconcile cause and effect, even when they appear to clash. A time traveler from the dawn of reality wouldn't need to avoid paradoxes. They'd be the paradox resolution, their very existence fine-tuned to stabilize the timeline rather than fracture it. Some physicists propose that closed time-like curves, loops in space-time, aren't just theoretical. They could act as cosmic circuit breakers, redirecting any action that would create a paradox into a harmless alternate path. Picture a river branching around a rock. The water still flows, just not where the obstacle sits. In this model, the first traveler's journey would be that rock, their presence subtly diverting events to ensure critical moments unfold as they always have. Ancient myths speak of fate-weaving destinies, of prophecies that can't be undone. These might not be fantasies, but intuitive glimpses of a universe hardwired to prevent temporal dead ends. Here's the chilling part. If the traveler's actions were designed to prevent paradoxes, then every historical event we perceive as fixed, every war, discovery, or accident might be the result of their unseen influence. The assassination of Archduke Ferdinand, the invention of the light bulb, even your own birth could appear inevitable because the traveler made certain no other outcome was possible. This doesn't erase free will. It suggests our choices are part of a vast, self-consistent tapestry where every thread supports the whole. The universe's first time traveler wouldn't be a rebel breaking the rules. They'd be the rules, a living failsafe woven into existence at the moment of creation. And that raises a mind-bending possibility. The reason we've never found evidence of time travelers isn't because they don't exist. It's because the best ones leave no trace at all. From the mind-bending idea that the Big Bang itself was triggered by a traveler from the future, to the eerie possibility that dark matter hides messages from a civilization that cracked time's code, we've journeyed through theories that don't just bend the rules of physics, they shatter them. Think about the Boltzmann brain, a consciousness conjured from chaos, or the simulation debugger tweaking reality's source code. Each of these ideas forces us to confront a single, staggering question. What if time isn't a straight line, but a mosaic of moments where past, present, and future are tangled beyond recognition? Consider how these theories reframe our place in the cosmos. If ancient structures like the Great Pyramid or the Nazca Lines were influenced by future visitors, then human history isn't just a linear march, it's a conversation across millennia. If quantum entanglement stitches together events separated by eons, then every observation we make might be part of a cosmic dialogue we're only beginning to decode. Even the universe's fine-tuning, those impossibly precise constants that allow life to exist, could be less about chance and more about a message written in the fabric of reality itself. What makes these ideas so compelling isn't just their audacity, it's how they force us to rethink the nature of existence. Are we the architects of our destiny, or actors in a story whose first page was written by a hand from the future? Is time travel something we'll invent, or has the universe already been doing it all along? The answers might lie hidden in gravitational waves, neutrinos, or even the silent hum of dark energy, clues waiting for us to look closer. Now it's your turn. Which theory resonated with you the most? Did the holographic universe's glitches send chills down your spine? Or did the cosmic string's natural time loops spark your imagination? Drop your thoughts in the comments. Let's keep this conversation stretching across time and space. And if you're hungry for more mysteries that twist the boundaries of reality, hit subscribe. The universe is stranger than we can imagine, and together we're just starting to peel back the layers. Remember, The greatest discoveries often begin with a question that seems impossible. So keep asking, keep wondering, and who knows, maybe one day you'll be the one to uncover the universe's next great secret. Until then, stay curious and keep looking up. The answers are out there, waiting in the dark.